These are the notes for 3-5 Part 2, Graphing Linear Equations in Slope-Intercept Form. For this particular section, we want to convert from standard form, which is ax plus by equals c, to slope-intercept form, which we know is y equals mx plus b. Equations written in standard form can be converted to slope-intercept form by just solving for the variable y. We're going to follow the following steps. Step 1, we want to add or subtract the x term. If the x term is positive, we'll subtract it. If it's negative, we'll add it. When we subtract it to the right side of the equation, we want to write the x term first on the right. And I'll show you what we mean in just a sec. What I mean by that is if we look at number 1 and it's positive 2x, so we subtract it from both sides. On the left side, we have y equals. Now on the right, we want to write the x term first. So instead of 3 minus 2x, we're going to write it as negative 2x plus 3. Let's keep the x term first so that it's in the form y equals mx plus b. Now remember, m is your slope and b is your y-intercept. So for number 1, the slope is negative 2 over 1, and the y-intercept is at 3. Step 2, we want to divide each term by the y coefficient. The y coefficient is the number in front of y, the number that's being multiplied times y. So let's look at that. Let's look at an example. So step 1, we want to add or subtract the x term. So for number 2, it's positive. So we're going to subtract 4x from both sides. So now we want to divide each term by the y coefficient, the number that's being multiplied times y. Y is being multiplied times 5, so we're going to divide each term by 5. Then we want to simplify. So we get y equals negative 4 over 5x minus 6. Which would make the slope negative 4 over 5, and the y-intercept negative 6. So our last steps, after we divide each term, then we want to simplify, make sure it's in y equals mx plus b. Then you can identify the slope and y-intercept, the m and b. This will help us when we get to graphing these equations. So let's go over some additional examples. Number 3, x is positive, so we're going to subtract it from both sides. We're left with negative 3y equals negative x plus 12. We're then going to divide each term by negative 3. So the equation in slope-intercept form is y equals x over 3 is 1/3 x, and 12 divided by negative 3 is negative 4. Our slope is 1/3. Our y-intercept is at negative 4. Number 3, x is positive, so we'll start by subtracting it from both sides. We're left with negative y equals negative x minus 8. Now negative y, that's not solved for y just yet. Negative y, we think of negative 1 times y. So now we want to divide all three terms by negative 1. So we get y equals x plus 8. Making the slope 1 over 1. And the y-intercept is 8. For number 5, 4x is positive, so we'll subtract it from both sides. On the left, we have negative y equals negative 4x. And same thing, we want to divide both sides by negative 1 to solve for y. So the slope of this equation is 4 over 1, and the y-intercept is 0. Number 6, positive 3x. So we're going to start by subtracting it from both sides. We're left with negative 2y equals negative 3x minus 14. Then we divide by the y coefficient. Once we do that, we're ready to simplify. A negative divided by a negative is a positive. Our slope is 3 over 2, and our y-intercept is at 7. The next example, the x term is negative, so we need to add it to both sides. We want to do whatever's opposite to be able to undo it. Remember to write the x term first, and then divide by the y coefficient. We also want to simplify any fraction possible. 6 over 4 is 3 over 2. In this example, our slope is 3 over 2, and our y-intercept is 5. Last example on this page is number 8. We have positive x, so we're going to subtract it from both sides. Five times y, so then we divide each term by positive 5. Negative x over 5 is negative 1/5 x. Making the slope negative 1 over 5. And the y-intercept is negative 3. So now what we're going to do is use this concept, and we're going to take it one step further and graph linear equations in slope-intercept form that aren't currently in slope-intercept form. Okay, so first we want to write the equation in slope-intercept form. So we're going to subtract x from both sides. Divide each term by the y coefficient. So So the equation we're graphing in slope-intercept form is y equals negative 1/3 x minus 1. The slope of this line is negative 1/3, and the y-intercept is negative 1. So we're going to start at the point 0, negative 1, and use the slope to create additional points. We want a negative line, so we can move up 1 to the left 3, rise over run. From the y-intercept, we can also move down 1 to the right 3. Once we've created as many points that can fit on our graph, we're ready to connect and extend with arrows. First step, solve for y. Divide each term by the y coefficient. Negative x divided by negative 1 is positive x, and negative 5 divided by negative 1 is positive 5. Making the slope of the line 1/1, and the y-intercept is at positive 5, which is the point 0, 5. So that's the point where we're going to start on the y-intercept. From there, use the slope of 1/1 to create additional points with a positive slope. From the y-intercept, we can also move down 1 to the left 1. Once we've graphed all of our points, we're ready to connect and extend. First step, solve for y. So we're going to subtract 5x first. Don't forget about that negative in front of the y. And try to write your x term first. Finish solving for y. Then we're ready to identify the slope and the y-intercept because now it's in slope-intercept form. So we're going to start at the point 0, 3 at the y-intercept, and then graph a line with a positive slope of 5/1. So move up 5 units to the right 1. From the y-intercept, we can also move down 5 units to the left 1. Graph as many points as you can. I'm going relatively quickly through these examples because they are kind of repetitive. At any point, you can stop this video and start your practice. Positive 4x, so we want to subtract it from both sides. Divide all 3 terms by the y coefficient. Simplify and write in slope-intercept form. Making the slope of the line negative 4/3. And the y-intercept is positive 7. So we're going to start there first at the y-intercept and make that point. From there, use the slope of negative 4/3. So we want a decreasing line with a slope of down 4 to the right 3. Once you're finished graphing, you want to make sure that if it's a negative slope, that our line is decreasing. That's as many points as we can fit. Connect and extend. (14), solve for y first. Positive 2x, so we're going to subtract it from both sides. We're multiplying y times negative 4, so we're going to divide each term by negative 4. And then simplify so we can write it in slope-intercept form. 2 over 4 is 1/2. 20 divided by negative 4 is negative 5. So we're going to have a positive 1/2 slope, so an increasing line. And we're going to start at the y-intercept of negative 5. From there, create your next point using a slope of 1/2. Increasing lines are moving up 1 unit to the right 2. Make that point. Up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. We can also move down 1 unit to the left 2. Down 1 to the left 2. Down 1 to the left 2. That's as many points as we can fit. Our slope was positive and we graphed an increasing line. 15, same thing, positive 2x, so we're going to subtract it from both sides first. In this example, there's no constant, so we're just going to divide both sides by 3. And we're left with y equals negative 2/3 x. Making the slope negative 2 over 3. And the y-intercept is at 0. So we're going to make our first point of the line on the origin, on the point 0, 0. From that point, we're going to graph a decreasing line with a slope of negative 2 over 3. So we can move up 2 units to the left 3 and make that point. Up 2 to the left 3. From the y-intercept, we can also move down 2 to the right 3. Down 2 to the right 3. Connect and extend with arrows. And our last two examples, positive 10x, so we're going to subtract it from both sides. Keep that x term first. Divide each term by the y coefficient. Don't lose that negative. So the equation in slope-intercept form is y equals 5 over 4x minus 3. Making the slope of our line 5 over 4. And the y-intercept is negative 3, which is the point 0, negative 3. So that's where we're going to start. We're going to graph our next point. We're going to graph an increasing line with a slope of 5 over 4 by moving up 5 units to the right 4. Up 5 units to the right 4. From the y-intercept, we can also move down 5 to the left 4. That's as many points as we can fit. So connect and extend. And our last example, we have positive 9x. So we're going to subtract it from both sides. Next, we're going to divide each term by the y coefficient. And then simplify so we can graph it. So the equation in slope-intercept form is y equals negative 3/4 x plus 1. which means the slope is negative 3 over 4, and the y-intercept is at positive 1. So we're going to make our first point at 0, 1. Next, we're going to use our slope to graph a decreasing line with a slope of negative 3 over 4. So to do so, we want to move up 3 units from the y-intercept to the left 4. Make that point. Up 3 to the left 4. From the y-intercept, we can also move down 3 units to the right 4. One negative direction and one positive direction. That's as many points as we can fit, so we're ready to connect and extend with arrows. That's it for graphing linear equations in slope-intercept form, 3-5 part 2.